Hi, welcome back to part 5, alright, of representing solutions to linear inequalities on the number line. And what I should have pointed out earlier was that these linear inequalities are actually the ones with one variable, right? As in just x. We'll explore that in other upcoming videos. Right, so this one includes a single variable. In this case, we're looking at x, and as I said, we'll go through that in the future. So let's continue with the number 4, right, where we have x less than or equal to 3. And what did I say we do again? First thing, we point out our 3 is in question here, right? And it doesn't matter which number it is, whether a negative or a positive number, the procedure remains the same. So we pointed out our 3, and the inequality reads x less than or equal to 3, right? And we circle right above the 3 right there on the number line. Go back for my magic ruler again, and I place it right here. Carry it up a bit more, right? And I draw my line like that, and I put on the arrow, because numbers that are less than 3 would be in this direction. But let's take a look at this circle right here. In this case, we would actually shade our circle, because the solution tells us that 3 is also included. It says less than or equal to 3. So 3 is included as well. So once the number is included, oh yeah, alright. This should be 3. So once the number is included, we'll have a solid circle, or a shaded circle. Now let's move on to number 5, right? Alright, let's turn this into a negative 4. Yes, x less than negative 4, because we have not dealt with any negative numbers. And always remember to write your inequality. So x less than or equal to 3. For number 5, that says x less than negative 4. You identify a negative 4 right here, put your circle, and what would we have here? A shaded or an unshaded circle? Let me see who was listening. Shaded or unshaded circle? Very good. We'll have an unshaded circle because of what the inequality tells us. Let's just draw this line, right? So to the left hand side of this circle, we'll find numbers that are less than negative 4. So the circle remains unshaded because there is no equal portion to the circle. We don't have that. So once you don't have that, the circle remains unshaded. And write your inequality. So for this part, x less than negative 4. And that's basically it for representing linear inequalities in one variable using the number line. Alright, so let's move on to a different phase here now, where we're going to represent these using the graph. How do we represent these on a graph? So let's explore that at the moment. So if I should, alright, let me use some random inequalities here now. So I'll call this one number 1. Let me change that color. If we should have x less than 2, right? What you'll do, you'll identify your 2, which is this, right? Positive 2 and not a negative 2. So you identify here 2. And if you have a different way of doing this, you can let me know, but I'm exploring this one for now. Right? And even though I might start out with a solid line, the line doesn't necessarily have to stay solid. I just draw it that way so that I can get the line. Magic ruler. Alright. So I started out right there. And this line actually represents x equal 2. Right, so that's a solid line for x equal 2. But in our inequality, we have x less than 2. So 2 will not be included in this. How we represent this portion or this inequality is basically by using broken lines to start with. Broken line. So similarly to how you would have the unshaded circle for the less than, we use a broken line here for the less than. So that's the first step. Right, so we use the broken line. Alright, so if you recall, when we have a less than, we only had a circle. We did not shade it. So when you have a less than, when you're dealing with the graph, you have a broken line. Right? So this is for the graph. So this one is for the graph. And the unshaded circle is for the number line. What was that? Let me get that out. Right? The unshaded circle was for the number line. Right, so in this case, we have our broken line to start representing numbers that are less than 2, but we're not finished there. And similarly to how you would draw the arrow in a specific direction on the number line, you're going to ask yourself now, on which side of 2 are there numbers that are less than 2? On the left side or on the right side? And if you said left, then you would have thought correctly. So once you identify the side now, you're going to shade the left side. Right? Shade the left side. Doesn't have to be perfect, but don't let it be messy. Especially don't let it cross over on the right hand side. So use your pencil, use your pen, and shade the left portion. Don't have to be the entire left portion, because you would actually shade until eternal God come, because it goes straight on to negative infinity. Right, so once you shade this, then you are well on your way, because this portion actually represents x. Let me use a different color. Represent x less than 2. And please be reminded that once we have just the less than sign, we will use broken lines to represent this line right here. Right? Broken line. So if it was a case where we had so less than or greater than, we use broken lines. Right? Less than or equal to or greater than or equal to, we use solid lines to represent those. Similarly, we would also use a shaded circle when it comes down to the number line, and an unshaded circle when it comes down to the number line again for those. Alright, so let's move on to another example. Alright, so I'm gonna call this 2. Let's have this as x greater than or equal to 1. Now, first thing that we do, we identify our number in question, 1, and it is not a negative 1, it is a positive 1. Negative 1 is over here. So our positive 1 would be right here. So we identify our 1. Then you look at the inequality now to determine which line are you going to have, whether a broken line or a solid line. Bring over the magic ruler over here, and I'm gonna draw my line right here. Right, my arrow. And if we should look at the inequality now, we'll realize that the inequality involves an equal portion to it. So once it has the equal portion or the equal part, we use a solid line, because in this case where we have x greater than or equal to 1, 1 is also included. So once 1 is included, we have a solid line. And if it is not included, in a case where we would have something like x greater than 1, then we'll have a broken line. So we're going to keep the line solid. And moving on to the other portion of it now, where we're going to ask ourselves on which side of this line are there numbers that are greater than 1. Remember, we have the equal to 1 already by drawing this solid line. So on which side are there numbers that are greater than 1, left or right? Very good, on the right side. So we're going to shade over this side. Why is ugly color? We're going to shade the right side over here. Remember, it doesn't have to be perfect, but you get the concept. And don't let it cross over to the left side. Ugly color, man. I'm gonna choose a nicer color next time. Alright. Everything over that side, straight up to positive infinity. Right? Yeah. So we write our inequality now. X greater than or equal to 1. Alright, so I see you getting the gist now. We're gonna do 2 more examples, because we want to cement this concept. So if you see it show up on any paper, you know that we went through it already. Alright, 3. So if I say x less than -3, right? What am I going to do? Identify my -3, which is here. Then we start to ask ourselves, unbroken or broken line, or solid or broken line. So just gonna draw this just to get this straightness. Right? Now if you look back on your inequality, we have a less than, right? Once you have just the less than and no equal to, then your line will be a broken line, because you only have less than. If we had an equal to on it, as I mentioned earlier, then the line would be solid. Right? So we got that part out of the way now. To choose a nicer color than the previous one. Now you're going to ask yourself, on which side of this broken line are there numbers that are less than -3? Right? And it's actually over to the left hand side. So you use your pencil or your pen or your highlighter and you shade over this side. Alright, shade over this side. Doesn't have to be perfect, you just need to show us the side that you're working with. Alright, and that will represent your solution. And I said write your inequality x less than -3. So thanks for watching this video, and stay tuned for the remainder of this video series. Thank you very much.